This video is going to show you how to use the, or to do the problems that end up using the equation where it is V equals delta D divided by delta T. Okay, so the time that you're going to use this equation is when there is no acceleration. So if it doesn't even mention the word acceleration, or it says constant velocity or something like that, and you know there's no acceleration, you can use this. Okay, now this equation can also change into V equals D2 minus D1 over T2 minus T1. Because anytime you have a delta, what that means is the final minus the initial of whatever you're dealing with. So final minus initial displacement, final minus initial time. You can also use any combination of those two. So you could have D2 minus D1 over delta T, or even potentially delta D divided by T2 minus T1. Okay, so all of these come from the same equation. They come from this. It's just expanding out the delta D and delta T. So what I'm going to do for this is I'm going to go through and I'm going to do questions 3 and 4 from worksheet 1. So you can see 3 is the question about your driving. It just gives you a velocity and a time. And then 4 gets a little more complicated with what you're dealing with. So you can follow along with those questions as you go through and do this. So what I'll do first is number 3. Remember, the first thing you always want to do is write out your given values. So as I go through and read that, I see I'm driving a car at 57 kilometers per hour. So 57 kilometers per hour is a velocity, so I'm going to put 57 kilometers per hour. Okay. As I continue, it says if you continue at this speed for 25 minutes, so that is my time. And because that's the time of the entire trip, I can just call that delta T of 25 minutes. I don't actually have a starting and an ending time. I just know the time in between them is 25 minutes. And then it wants to know what distance will I drive. Again, I don't have a starting or ending distance or displacement. I just want to know the total amount I went. So I'm going to find the change in that distance or displacement. And don't get hung up on the words displacement or distance in terms of when you're solving these. We're actually finding a speed here, so it gives us a distance. But again, we're going to use the same equation either way. And I'm solving for that. And it doesn't ask for a specific unit. If it asks for a specific unit, make sure you pay attention to it. If it doesn't, just take whatever distance unit of velocity you have up here. So this is in kilometers. So I'm going to find mine in kilometers. That way I won't have to do, or I'll have to do the least amount of conversions. So what I'm going to do right here is make sure all my units match up. So that's the first thing I'm going to go through and do. So kilometers per hour, minutes, kilometers. Kilometers match, but minutes and hours don't. So I have two options. I could either change this to kilometers per minute, or I could change this to hours. Either one will give you the same answer in the end, but I'm going to change my minutes, and I'm going to go from 60 minutes to 1 hour to get that value. So 25 divided by 60 is going to be your new time, and that is going to be 0.42. And this is now in hours because my minutes canceled out. So I'm going to get rid of this over here where I had 25 minutes, and I'm going to replace it with 0.42 hours. Once all your units match up, go ahead and solve the equation by figuring out what you're going to need to do. So the first thing I'm going to do is write out the equation I'm going to start with. So since I have V, delta T, and delta D, I know I'm using this equation. So V equals delta D divided by delta T. Now, do not plug in numbers yet. Go through, solve all of this with the variables first. So I need to find delta D. So what I'm going to need to do, multiply delta T to both sides. And I get delta D equals delta T times V. You need to get this listed as an equation with all letters, solving for whatever you need first before you do anything else. Okay? So this is what I'm saying whenever I'm saying do the algebra with letters first. This is completely solved for what I'm trying to find before I plug in numbers. Once I plug in numbers, I should just be able to write it down in terms of 0.42 hours times 57 kilometers per hour. And then I should be able to plug it straight into my calculator, which I can't. So 0.42 times 57 gives me 23.94, and since this is a distance and that's kilometers right there, it's going to be kilometers because my hours canceled out. Okay. On the back of the answer sheet, I have 23.7 kilometers. So I did this a slightly different way, or I rounded a little different than compared to when I did the answer key, and that's fine. If you're off by a little bit, that's okay. All right, so what I'm gonna look at right now is we're gonna go on and look at number 4. In number 4, it's just a little more confusing because you gotta pay attention to what it's actually asking for. So this is the question where it's telling you you're running late, you need to hurry up. You're trying to get to a job interview that starts at 3:30, all right, and it's currently 2:15, but you want to get there 10 minutes early. So we know that our starting time, T1, is going to be 2:15, and our ending time is going to be 3:20 because we're going to get there 10 minutes early of 3:30. So I can look at these right now. Anytime you have something with a clock, like a time that you'd see on a clock rather than just minutes or hours, find your delta T right away, okay? Because you can't just subtract 3:20 minus 2:15. It's not gonna work out right sometimes with the numbers because there's hours and minutes mixed together. So don't do it that way. Just think about what's happening. It's an hour and 5 minutes, which is the same thing as 65 minutes. So that'll be my change in time. The other thing that I know is I have to travel a total distance of 75 miles. Okay? And if you keep reading, you're going to see later on it says 65 miles per hour. But if you read the question carefully and don't just pick out numbers, you'll see that's a speed limit that you're going to compare your answer back to at the end. What you actually want to find is your average speed that it takes you to travel 75 miles in 65 minutes. All right, so what we're going to have to do is go through and find V. Look at what we have. We have delta D, we have delta T, and we're trying to find V. That's why we're using this equation right here. But we want our speed in miles per hour. If I did it right now, I'd get it in miles per minute. So I'm going to change this 65 minutes. It's going to be the exact same conversion we just did. 1 hour on top, 60 minutes on the bottom. And I'm going to get something that should be just a little over 60, 1.08 hours. So I'm going to change that right away, 1.08 hours. All right, so that's what I have right now. Now my units all match up. I can go through and use the actual equation. I am going to, again, start with the equation. V equals delta D divided by delta T. Okay, and I forgot what I was solving for over here. I wanted it in miles per hour. So see how what you're solving for is already set up here? That's good. So I don't have to do anything else to this equation. I'm going to then plug in the numbers. But still, even if it's just for V, don't just plug in numbers right away. Write what the actual equation is. So delta D is going to be 75 miles divided by 1.08 hours. So when I do that, I'll get a final answer of 69.44 meters per second. Okay, and that is my velocity, my average velocity for the trip. So the final question asks, if you don't want to break the law and the speed limit's 65 this isn't meters per second, this is miles per hour, because I did miles divided by hours. But the speed limit's 65 miles per hour, and my average has to be 69.44. So I would have to average a speed above the speed limit. So can I make it there without breaking the speed limit or breaking the law and going above the speed limit? And the answer would be no for that.